when you at some point might ask me what's the difference between LLMops and MLOps, so I think that the short answer is that even if the chain of thought is very, very long and complicated, in the end, the reason you're tracking it is not because you know what you're going to do with it, is because you don't know what you'll need in the future. Machine learning was only good at interacting with tabular data. And the real world is, unfortunately, for a lot of us, not tabular. And so the LLM revolution, in many senses, is a revolution in which...
Dean Pleban is the CEO of DugsHub. He spent the last 5 years talking to thousands of ML operators and founders. And in this conversation, we dive really, really deep and take all the insights out of his experience setting up and talking to people who set up ML projects and LLM projects, from the toy example in Jupyter Notebook all the way to full-scale, fully blown production-grade ML operation. He brings insights on how to use LLM as a judge and what are the differences between classic ML production-grade projects and LLM projects. So I hope you enjoyed this conversation. Dean, the CEO of DugsHub, thanks for jumping on this opportunity. It's been some time.
It has. Thank you for having me.
So in case for anyone who's been living under a rock, how old is DugsHub? Is like 4 or 5 years?
We've been running for 5 years, yeah.
Just drop a line on like how you guys come up with the idea, what you guys are doing. We're going to have a full conversation on where Gen AI is going, what you have seen practically working on projects and best practices, but just to give context.
Sure. So I'm Dean. I'm the co-founder and the CEO of DugsHub. What we're doing at DugsHub is we're basically, we started the company with a vision that I think has stuck with us until today. The implementation details have moved around like everything else, but the original idea was that getting software to production is relatively straightforward and well-defined at this point. So 5 years ago, it was true as well. But getting AI to production is much less well-defined. And so we set on a goal to make that process easier and as painless as possible, in the hopes that it will actually sort of accelerate AI adoption, make it, as we saw it would be the case in any way, exist in any vertical and any walk of life and make a real impact on the world. And again, just to give context, this was way before ChatGPT, and what is now clear to everyone is the case. And so the original idea was mainly to focus on data in addition to code, which to us was the other input that you have in machine learning. So we were trying to build something that you could think of as like a GitHub for machine learning or GitHub for data. But at some point we realized that data is not enough, and there's also the experimentation process and model management which need to be involved. So today, DugsHub is a platform that is basically covering the processes of data curation, dataset building and annotation, and then experiment tracking and prompt tracking in the LLM world, and then model management and evaluation all the way to where you deploy the model wherever you need it to go. We support any type of data, but our emphasis is on sort of the unstructured type. So text and image and audio, video. And what you're saying, so and this also relates to sort of the AI revolution. I think that for a very long period, machine learning was only good at interacting with tabular data. And the real world is, unfortunately, for a lot of us, not tabular. And so the LLM revolution, in many senses, is a revolution in which AI is now much better at interfacing with the real world in the way that humans interface with the real world, namely talking to each other, writing to each other, seeing things, hearing things. And so I think that that's also why we're focusing on this. Like, there are some solutions that focus on the tabular world, but we wanted to help people build models that actually interact with the real world.
And the real world tend to be unstructured.
Exactly.
That's very cool. So yeah, I remember when you guys started, it was like, I think it was even like the one-liner was like the GitHub for data science, where people couldn't manage their dataset sourcing, like version controlling for datasets. I wonder if is that been like solved? Would you say that's like 5 years later, is that already like a solved problem, or still people are finding this challenging?
So I think that building models is still very challenging. I just had a conversation yesterday. the challenge is
When you say
sometimes,
just like when you say models, you're
yeah.
talking like classic ML or
Oh, no, no.
working
So
with.
yeah. So everything. So okay, that's a good point. The way I'm thinking about this is that model is a catch-all term because it's very hard to clearly define it without like writing a full white paper.
Mhm.
Catch-all term for any box that receives input data and does some sort of sophisticated, probably learning-based algorithm and then outputs something. It still applies to you using like GPT-4 as an API, pushing in some context from your data, and then getting a response. And the reason is that even if you're not the one actually training the base model, there's a lot of complicated process that you need to go through to manage the fact that the data is not necessarily the outputs are not necessarily predictable and very, very impacted by the data that goes into the model, right? So
Yeah.
a lot of the work that we've been doing is trying to standardize that process so that you can make sense of what's working and what isn't working for you, if that makes sense.
If we do like a really like a box diagram of, you say, let's say if this is a what you defined as like a model, which is it could be like a cloud sonnet, and it could be an SVM, and it could be a KNN and whatever, right? Like filling, like sort of like fill in the blank, right?
Sure.
You say we want to standardize the whole thing. When you say standardize the whole thing, you talking about like, let's say like this like maybe we call this like pre-model or sometimes
Uh,
people would consider this part of the ETL, right? Or like the data wrangling,
sure.
you cleaning the data, right? Or in terms of, you also talked about structured output. I'm sort of like taking us a little bit more low level to really understand where you think there's a lot of value to be gained for teams focusing on, one or the other parts.
Yeah. So we can talk about what the development process looks like. I think that roughly speaking, there are um, three main stages, right? So call it pre-modeling, modeling, and post-modeling or something like that. But the way I usually think about it is that there's a data set building stage or data set curation or data set, I don't know how you want to call it, but there's a part of the workflow where you're building your data set, okay? And that data set might be used and it would actually be plural, right? So data sets. That could be used for training a model if you're fine-tuning or LoRaing an LLM, for example. That can be used to evaluate the model or evaluate the prompts that you're trying. So that would be like another data set. You could argue that you need that after the model. So the evaluation phase happens after you have a model, but usually building that data set is much more tied into the problem definition. And so it usually should happen before you're experimenting with the model. Like, what do you want this model to be good at? And that relates to building the data set. The second stage is the experimentation stage. So in the classical ML, and this is like foreshadowing what I'm going to say about when you at some point might ask me what's the difference between LLMops and MLOps. So I think that the short answer is that there's not a lot of difference in the high level things that you do, but the low levels obviously change to accommodate the differences in models. So the second stage, the experimentation stage, in classical ML, this would mean like fitting anything from a linear regression or SVM to XGBoost or whatever. But then in AI or in the LLM world, this would include the prompt engineering. It would include model selection. That's an experiment, right? Should I use Claude or ChatGPT or self-host Llama 7 billion, right? So this is part of the experimentation phase. One thing I didn't say about the data preparation phase. So if you're building a RAG application and preparing that data sets for context retrieval, that's part of the data set preparation. So just to
Right.
make that clear.
It would be like basically, which is, this is like, there's like the context phase, which is very much sort of like defined by the problem space on or what you're trying to achieve, right?
Sure.
And then there's like basically like model fitting or model choosing feeling sort of phase.
Yeah, exactly. And then in the experimentation phase, you might also experiment with fine-tuning. We've spoken to people. It's not common, but it is happening that people are actually fine-tuning LLMs as well. Usually LoRa's, so not like fine-tuned from like, not like classical fine-tuning, but still they're actually customizing the model weights. And then the last phase, you can call this like evaluation or pre-production or something like that. And of course, I'm sort of putting aside the whole deployment process, which I think does also have special components that are LLM related, but I'm again talking about the point of like building your application. So before you're deploying it. So for here, you've experimented, you found some things that work, and now you want to make sure that this sort of passes all of the exams so that you know that it's worthy to go to production, right? So we're basically going to look much deeper into our model. We're going to make sure that it not only improves on the task that we want it to be better at, but also that it doesn't become, racist or biased or whatever, right? So there's a lot of these things that we want to test off the bat. And of course, again, like I guess you could wrap this or add a fourth stage, which is like the deployment production stage. That would also have guardrails. So in addition to eval, you want to check in real time that your model isn't being biased or racist if you can. You probably want to report back samples from your customers if you're allowed to do that, and use that for both monitoring but also improving the model in the next iteration. And of course, the deployment process might have a lot of unique things that you need to address, like, for example, that in the dataset building phase, you have a lot of things that are happening in a static way. If you need to deploy those processes to production, many times, like, you get to the challenges of deploying data pipelines, which are, again, arguably pretty similar between LLMs and non-LLMs data pipelines, but you need to think about those as well. So this is my, off the bat breakdown. I hope I'm not forgetting anything.
Obviously, there are products across the full, this sort of like pipeline. Where do you think you guys fit, and like why? I mean, you talked about why you chose to work with unstructured data. I wonder if there is like a reason, probably in the earlier years or maybe still ongoing, that you've chosen specific area in this pipeline to focus on.
Yeah, so I think that the thing that we invest the most amount of time in is the dataset part. We do also provide components in the platform that cover the other two part, like the deployment. So DAGSub covers all three of like dataset management, experiment management, model management. And we basically get you to the point where you have like a model registry, and you can use that to deploy your stuff to production. So we bring you all the way to the red square in your diagram. But the core focus, the thing that we've invested the most amount of time in is the dataset part. To us from day one, like, data is still the hardest thing to handle in the data science and AI realm. And so that's what we're doing, or what we're bringing as much power to the users as we can. And I can talk about the specific features that we have at DAGSub, but I want to sort of maybe take a step back based on conversations that I've had, and just say that if you want to like simplify this to the most like basic format, each one of the green squares here can be a cell or a number of cells in a Jupyter notebook, and you can get to where you want to go through that, right? Like, you can have a cell that has a title dataset building, right? Yeah. And there's really great tools right now that give you, infrastructure for vector search or like proper RAG, and you can look at your data and like massage it with everything from like pandas to other like tools for those things. In experiment tracking, in a sort of prompt tracking, model selection, you can manually like try out different prompts and see what works well, what doesn't work well, maybe save that to a CSV because you don't want to lose it. And then for eval, you can do the vibe eval stuff. There's tools. There's actual tools though that help you structure this. So someone today sent me a really good model for hallucination detection. There's RAGAS. There's stuff like that. So you don't have to use a platform, right? But what we're trying to do is just make all of this more convenient. Create a record that actually lasts, so that you can share this with other people that you're working with. You can look back at what you did a month ago and not lose your sanity or hands or feet looking for the pieces. And concretely in the dataset part, we like at DAGSUB, what we're doing is we're scanning piles of unstructured data. So we would connect to your storage bucket. We would scan it and build a dataset. And then you could query it and filter it and look at different subsets. You could still in the data part, you could do like things like RLHF annotation or ranking, which is sometimes you need this mainly for the eval part, but theoretically also for if you're actually trying to run RLHF or some LoRa process, then that could be useful. And then of course, like regular annotation, which might be relevant for the fine tuning if you're doing that. On the experimentation front, we would help with like the prompt engineering and actually tracking the different prompts and models that you were doing, what worked well, comparing different models and things like that. And then on eval, you can actually report the eval results to us and then visualize and compare them to understand which models are working better. So
I like the like how you. I'm trying to break it down with you. I like how you sort of like you broke it into, and this is I mean, yeah, shout out to DAGSUB. Like I think great company, but this is more generalized discussion for anyone obviously trying to get a grasp of how to get started, right? To go about it, which I really love how you break it down into these like two sort of like levels where like you can use like if you need to vectorize something because you want to find similarity between things and you need to figure out the distance between vectors, then you can use vectorization with like ChromaDB or Pinecone, and there are libraries, and you can do it in a Jupyter notebook. But I think what's really interesting is like how that part, or like even like scaling eval to not be like vibe eval, like how like what are the best practices basically to do it in like the next level, which is like production ready, production safe, like we mentioned guardrails, right? So like on each one of these, even like 4, what have you seen that clients been asking, or the market is going towards for each one of these? Where obviously I think, or maybe you correct me if you see otherwise, but maybe companies are starting with the manual basic level, like the newbie kind of level. Let's do something with Gen AI. And then moving on to, we need this in production.
The example I gave of literally having a Jupyter notebook with a cell for each one of the green boxes, that's not figurative. I spoke with a person, I don't think I can mention the company name, but I spoke with a person in a very well-known company, and this is what they do. They have a notebook. They have a lot of data sensitivity issues, and there's a lot of challenges with that. But basically, he has a notebook. He does all the processes in notebook cells, and then he hands that off to a team that helps him deploy or helps them deploy the different the application version. So necessity is the father of all invention and all that stuff. You don't have to go crazy. I will note, however, that like as a counter argument to what I'm saying, one of the problems with Gen AI is that it's very easy to manufacture example or even multiple examples where your application is amazing, but what you actually need is that like 99 percentile performance for it to go past from sort of a POC to an actual production application. There are exceptions to this. I've spoken in the past about like the 2 axes of whether or not you can deploy an LLM application to production. So we can talk about that in a moment. But I'm going to put all of that aside and talk about like what would be, let's say, V2, right? So V1 is this notebook, and you're just doing a cell for each one of these processes. I think that V2 for the dataset building part is, one, you need to I mean, there is a part where you need to understand the scale of your data and everything, but theoretically, what you need to do is you need to have a system that lets you track the versions of your data sets. Specifically, in the case of RAG, where you might have maybe your raw data set is like, I don't know, whatever, 100,000 documents. That's pretty big, right? Or something like that. But what you'd actually be doing in this RAG context is you're chunking the data in different ways. That's part of the things that you can experiment with. So you need to version or manage how you're chunking this data in order to be able to, again, revert or understand what's changed and why a certain version of the application is working better than it isn't. You can do that in multiple ways.
Basically, if you don't version control your data, you're pretty much lost because you don't know what goes in. You wrongly evaluate what goes out. Really bad, right?
Yes, but I guess what I'm saying here is that with RAG, you have a slightly more complicated than the basic level of versioning, because you should in general like version the raw data, assuming it's going to change. And again, there's multiple ways to version depending on the scale of data that you have, whether it's add only or you're overwriting data and things like that. But if you're thinking about chunking, right? So you might chunk your data, the same raw data, you might chunk it in 1,000 different ways. And then you have this like explosion of ways to chunk your data, and you want to track those. Now, you don't necessarily have to version the outputs of the chunked data. You might just find the way you chunk in a deterministic way and then just version the code that does that. But you need to think about this, right? So this is like V2, you need to start thinking about what processes am I going to put my data through, and how am I going to manage that in a way that is reproducible? The other thing that you get in sort of V2 here is that in addition to all of these sort of maybe arguably straightforward things, you might have additional metadata, and you're going to need to make a business decision on whether that's going to go into your RAG retrieval process or not. And this is, again, an experiment that you might want to do. Like, if I add this metadata, does it improve the results or not? And then aside from this, so everything I've talked about up to now here relates to the RAG side of things. But aside from this, you're going to need to build at least one data set, like more classical data set, if not two. So if you're not fine-tuning, you just have one. If you are fine-tuning, then you have the fine-tuning data set as well. But you definitely need to start building your evaluation data set. And again, the reason you want to do this before you get to the eval phase is you want to make sure that you're holding yourself to a correct standard and not moving the goalposts to make you feel good about yourself. And
so like when you say eval data set, basically for like the classic ML guys, this would be like the whys.
Yeah. Well, it's I guess when you say whys, what do you mean?
Yeah, like in the in a classic like in like classic ML where like your why is like the correct, like the answers, right? Like the
why, like the letter. Okay, sorry, I was thinking about like, why.
Sorry,
like asking why. Fair enough. Yeah. So it would be the whys. It would also be, aside from the basic failure modes that every model needs to pass. So again, you don't want your model to be racist, probably. That's a generic thing. You could probably use a tool off the shelf that does it. But you might have failure modes that are use case specific, and you're going to need to build the data set to test for that or to optimize for that, right? So again, it's not just an eval data set. It might be a fine-tuning data set. But the general idea is, just to give a concrete example here, if you're building, I got a message from my sister. She's planning a trip in Europe, and she used ChatGPT to plan her trip. So let's take like a trip planner chat application, right? Or something like that. So one example might be like, okay, here are examples of requests and really good trip plans. But another example might be you might want to build a eval set that forces the model to give concrete references for hotels, right? In my example, and make sure that those hotels are not shut down, right? Or something like that.
Yeah.
So you might want to build a data set for like this specific failure mode, which is not just, it can plan the trip well, but I want to make sure that it gives me recommendations for places that still exist or still open. And that's not under the whatever. It's not a toxic response. It's not a biased response. It's just incorrect in a very specific way that you care about. So those are the main, I think, points about data set building.
Yeah. No, that's like really for anyone listening to, in companies doing V1, thinking on V2, I think this is really worth paying attention to. And so, yeah, and the last part here you mentioned, I captured it as like your guardrails. Like if you are working at an insurance company, you don't want at any point if it's all automatic, you don't want your model to reimburse or agree to a claim that is above X million dollars, right? Like it's just a context dependent, product dependent guardrails.
Yes.
So what would like the similar V2 look like when we talk about experimentation?
Yeah, so V1,
I'm
I
putting
think
you on the spot, but that's the life of a CEO is hard,
no, this is fine. I'm having fun. So V1 is easy for everyone, right? You just if you're doing this in code or a UI, it doesn't really matter. You're building like your prompt and you're just changing it around and just like clicking enter, enter, enter until you say like, oh, this one looks pretty good. Let me try a slightly different input and see if that works. So that's V1. V2 is first and foremost, you just want to track all of that, right? So you want to be able, it's not something that should be expensive, right? It's just text. And you want to be able to tie in the decisions that the model, or even in agentic workflows, like maybe you have a chain and you're calling tools and things like that. You want to track all of that. And when I say track, I mean in like an actual proper place of record, right? So doesn't matter which one you use, but the main idea is that you should be able to answer the question. 2 months ago, we had a model that we were really happy with. I remember we tried it on 10 different prompts. What was the model doing in those prompts? Like, what was the context? What were the specific parameters, temperature, whatever it is you're using? What was the response? Why did we like it? What version of the LLM, if it's like an API, what version of GPT-4 or Claude were we using? So just tracking all of that in one place of record that you and other team members can look at 2 months from now, that's already, I would say, V2. Unfortunately, maybe this is a very low bar.
It's just, basically, I guess I'm assuming what you're saying, which is not surprising, but not very good, is that the V1 phase happens, but sometimes there is no necessarily, in some companies, very good track record of what actually was done. It's like we show management our AI project. We say, yeah, we used Claude from Anthropic, but we don't really marry together the prompt used at the exact date with the exact model, or maybe like the model we used and like the context window.
Yes.
Or if we use an agentic flow, it's even more complex, right? Like there is no snapshot of what actually happened.
Yes. So definitely this is true. I'll give an even more horrific failure mode in a moment. But so V0 is just not, or V1 is not tracking it. V1.5 is tracking it in like a CSV or Google Sheet where you're manually copying stuff. V2 is actually having a system of record so that you're not sort of dependent on you remembering to do this in order to have your information tracked. You could say that V2.5 or V3 is also tying that prompt or experiment to the data. So the optimal, I would argue, the optimal case would be that when I'm looking at this prompt, I have a button that says like, show me the context. And in the context, I can see the chunks that were retrieved, but I can also say, show me where these chunks are coming from. And that will guide me to the raw data that those chunks came from. And that should be also easy for me to do, right? Even if those chunks have changed over different versions and things like that, I can tie back to the original raw data, raw source, like really understand how my result came to be. And of course, in the experimentation phase, if you're doing model selection, so comparing between different models, you want to track those tables as well. And if you're doing fine tuning, then you want to actually, or LoRa, whatever. LoRa, just I guess so I don't say this every time, LoRa equals fine tuning from my perspective here, even though there are different ways to fine tune models. But basically, if you are fine tuning your model, you want to track the parameters for the fine tuning, you want to track the process. And ideally, you would also want to understand why the process worked, right? Which is that's a tall ask. That's maybe V4. But unfortunately, I've also heard the story of companies that have a really good LLM and they have no idea why it's really good, and they can't upgrade because every upgrade is worse than this random success that they had. And so that is, I mean, that happens also in non-LLM ML world. But because LLMs in many ways are more of a black box, this would be optimal, right? Like if you knew that this set of parameters is what makes the model good, or that this data set for fine-tuning is what led you to this really good version, that would be a really powerful understanding. But this part specifically, this last part, I think is hardest in like Gen AI, even compared to other forms of ML.
Yeah. Like I was gonna say, the white work part. It's I think in many cases no one knows, right? Like there's with reasoning models, you will have better chance if you work or even if we're talking about agents, if you work in verbose mode where like the reasoning is spreading out, you save it and you can backtrack sort of like the line of thought produced by the model. But if you're using the non-reasoning models, which according to OpenAI, those belong to the past, right? Then you might be in trouble. So I wonder. That makes me think. Have you had conversations on, and that's probably very recent, on saving this sort of like the reasoning chain of thought that the reasoning that the model produces and spits out? Is that something people keeping track of over time?
So I'll say two things. One is when I say why it worked in this context, I don't mean a philosophical, air quotes, explanation of why it worked, because that's, I agree, you will probably never know it. But what I mean is more along the lines of what is unique in this experiment that I ran that went very well, so that I can repeat it with the next model or next whatever, right? Like you have to understand what changes you're applying.
Like what did you do that
yes,
works,
exactly.
and not why the model is good?
Yes, exactly. So like that the model is good because hopefully you have an eval set and it sort of proves to you that it's much better than the other things. But now you sort of want to make sure that you track not just correlation but also causation. Like saying, oh, in this version that was really good, what I changed is we chunked the data in a different way, plus the version of the model was updated, plus the data set for fine-tuning was this. And then you can sort of try out these different variations with the new model or whatever you're trying to see if that yields good results. It's not a foolproof system because sometimes, again, correlation and causation are confusing. You think the reason the model is good is A, but actually is just random and you were lucky. But in many cases, it can lead you to sort of pinpoint like, oh, these set of prompts or this data set is really, really powerful, and we need to make sure that we still have access to it, that we're like, taking care that it doesn't stagnate, and that we create more samples within it or whatever, right? So that's sort of what I'm going for. But to your second question about tracking the like reasoning chain, I am honestly not sure. I would assume that most of the frameworks that exist today that track the traces would include tracking the reasoning part, but I haven't tried it with like the latest reasoning model, so I'm not sure how this looks like in practice. The recommendation would still be to, yes, of course, track it as much as you can.
If you can, right? Yeah, then
the more the merrier. There's literally no such thing as tracking too much, I think, as long as you can filter.
And then like in the case of like DeepSeek, if the reasoning being spat out is really long, eventually you can have an LLM analyzing the different reasoning chains across time and telling you the difference if you're too lazy to go over them.
So we can talk about LLM as a judge as well. I think that there's a lot of room for using LLMs to improve the LLM building workflow, right? But yeah, I think that even if the chain of thought is very, very long and complicated, in the end, the reason you're tracking it is not because you know what you're going to do with it, is because you don't know what you'll need in the future. And so the recommendation is to track as much as you can and then figure out what you need later on. Again, in most cases, I could probably think of extreme outliers, but in most cases, for this specific stage, so I'm not talking about like preserving all production inputs. That's like a problem of scale. But preserving all development inputs, that's not such a big deal. So it shouldn't cost you too much to do this. And the potential gains are huge.
Mm-hmm. So that kind of leads us to talking about the LLM as a judge and eval. So when we said in V1 or even V0, it would be like the vibe eval of like looks LGTM, right? Like looking good.
Yes.
Looks good to me.
LGTM is...
Yeah, it's like a classic GitHub all-time comment.
Yeah.
But what would be like a more standardized way to go about here?
It's a good name for an open source of LLM evaluation. You can take the copyrights.
Best benchmark, right? We can offer Scale AI to have the LGTM benchmark.
Yes, exactly. So V2, I guess adjust a lot of things here. I'll try to caveat each one with things that I've actually seen people do in production versus things that I think are theoretically good, but I haven't talked to anyone that has this in an application. So like move forward at your own risk. It might be really hard to implement, right? So, so stage one, and I think this is relatively easy to implement. And so if you're working on something and it's more or less in production, you should probably do this, is just use one of the open source frameworks to at least test your model against the basic stuff, right? So testing for toxicity and harmfulness and things like that. There are, I don't want to say good, because good is like what we think is good today is going to look ridiculous. Like I remember when GPT-2 came out and people were like, wow, this can actually say things that somewhat make sense. And then GPT-3 was like, holy shit. And then ChatGPT changed the world. So it's going to look different, but I think there's already good frameworks for doing this today, and they're open source, so why not? So that would be like the very, very basic thing you can do. The second thing you can do is, if you are doing the LGTM method, you can start logging the things that you were sort of prompting to test and building a data set from them, right? So again, my high level recommendation is to do this before you're experimenting. But let's say you disregarded my recommendation and we're here, right? So now instead of just running it once, like run it and then save it to a data set that you're going to use the next time as well, right? And you can automate this process with, even PyTest, right? That's a way to do eval. You don't have to use something fancy that was purpose built for LLMs, right? And that will still bring you to a much better place than a lot of the people doing this. So yeah, start building a data set from it and then testing against that over and over again. And here, what you can do is you can start.
What do you when you say the LGTM data set? Like what do you? I'm not sure I'm following in terms of what do you see in your mind? Is that like, are you suggesting to just have a more concrete cross-team definition of what is good enough for looks good to me? Is that like internal benchmarking?
So yes, I mean, maybe concretely, let's say there's a team of 5 people and they're each working on like improving this LLM system. The LGTM method would usually consist of like running a few prompts that you think are challenging to the model, and then just eyeballing the results and saying like, okay, this looks pretty good. I think we can go to production. Again, real teams, real production use cases, that's what they do. So you're in good company if you're doing this. But what I'm suggesting is it might be trivial to some people that are already doing this. But if you're not, instead of like running these prompts, put them in an actual object and have other team members add theirs to that object. And then instead of like running each and every one runs whatever they think makes sense, actually like automate every model against all of these samples and look at the results. Now for this eyeballing phase, so you would start, maybe you already have this data set, right? And you're running this. The next step would be to try to automate this process. And one way you can do this is with LLM as a judge. Smarter people than I have written a lot about this. There are some cases in which it works, other cases in which it doesn't, and you need to figure out if it works in your case. But the best idea, in my opinion, for this, right, is that LLM as a judge works better when you can provide a more categorical output to what you want this LLM to judge. So, to give a concrete example, if we're in the travel planning chatbot that we discussed earlier, if the test prompts that I'm giving it are like plan a trip for 2 weeks in Italy, right? And then I want to evaluate whether the answer is good, that's going to be very hard, right? Like, what is good? And then a human needs to look at this. It's also very long text, so that's going to take a long time. It doesn't work very well at scale. So you can do this with like 5 or 10 or whatever, maybe 20 prompts if you're very diligent. But the actual next step would be, let's break this down into things that we care about. So for example, if I'm asking for a 2-week plan, does the plan that comes out cover 2 weeks, right? That's a yes or no question. And so then you can use an LLM to judge this. But let me take this to another step. There's a very good blog by the wonderful Eugene Yan, who talks about, in this case, you can arguably build a data set that is a classification data set, right? Because yes, no is 0 and 1. And then instead of using an LLM as a judge, which is kind of a black box, right? Like you're trusting GPT-4 to understand your task and classify it correctly, and that it might hallucinate, and there's a lot of problems with LLM as a judge as well. Instead of doing that, you can actually build a data set, okay, of these yes/no questions. And you start by building this manually, okay? So what I mean by this is you have a curated data set that a human has created for, in my very stupid example, plan a 2-week trip to Italy. Here's a trip. Does it cover 2 weeks? Yes or no, right? And so you build, let's say, 50 of these examples, okay? Which is time-consuming and annoying, but takes less time than you think and might change your life from an evaluation perspective. I'll explain why in a moment. So after you do this, what you don't do is you don't shove this into a model immediately and hope that it works. What you actually do is you give these examples to GPT-4 or Claude or whoever, and you ask it to generate 1,000 or 2,000.
Oh.
And then what you do, we're not done yet. And then what you do is you take a very simple language model, so a BERT or a BART model, and then you fine-tune that model with a classification head on the why, which is yes or no. And so just to explain what we did here, we went from a relatively amorphous question to one where I can use a cheap, relatively or very deterministic model, because I manually fine-tuned it to have a classification head, so it only outputs 0 or 1. And I effectively created a pass-fail test that has as input free text and as output, does this cover the user's requirement of like trip length, for example. And you can do this with 20 different tests. And so you suddenly brought it from like this fuzzy LLM as a judge. How do I prompt engineer the judge LLM so that it judges a prompt engineered LLM well, to something where it's like, oh, this is the same as running PyTest, right? And it, again, much cheaper and faster than doing it with large and heavy LLM.
No, this is gold. Yeah, where people can go to learn more. It made me curious.
So I take 0 credit. I love this idea, but I take 0 credit for it. It's Eugene Yan. If you go to eugeneyan.com, it's his blog. He's a very smart guy, and he has like a blog about this specifically. He also has a blog about evaluating LLM as a judge evaluators. So
Going meta.
he writes a lot about this, and a lot of my ideas, like I've spoken to him. A lot of my ideas are influenced, you could say, by him and other people's work. I think it's wonderful. And I'll say another cool thing. Again, this last one. So this example, I've heard people have in production. I heard from people that they have it in production. One more advanced thing that I haven't spoken to people that actually have this in production, but I think is really cool. For cases where you can't do what I said, right? Like you have this, in the end, you want a fuzzy matching, right? To like, what is the optimal output, and you can't really make it classification task. In this case, one solution, and again, it won't work in every case, but one solution would be to build an eval data set. Again, in my stupid example, trip requests and trip plans. And then what you would do is you would, and this is like manually curated, right? So you know that it's good because you created it. And then what you do is you would ask the model that you're testing to like generate the responses to these prompts. And then the problem is it's never going to be exactly the same, right? Because it's generative models, they have some level of flexibility. But then what you do is you would embed both the generated responses and the responses that you wrote. And then you would do sort of vector similarity or cosine similarity on those vectors. And then the advantage of this over the classification methods is you get a spectrum, right? So it's not 0 or 1, but you could say like, if it's 1, then it's exactly the same response. If it's 0, I don't know what that would mean in this case, but it's like totally off, right? But now you have this gradient where you say like, oh, I see that this model got 0.6 and this model got 0.8. So maybe this model is better, right? So this is like more advanced stuff. Again, I haven't spoken to anyone that has this in production, but I know that people are excited about this idea, and some people are trying to implement this.
So basically, get the output and then use the same embedding method on the same n-dimensional space to see the distance between your answer and the output, and just minimize the distance over time.
Exactly. So that would be a way that is, you could say, I mean, I don't want to use wrong terminologies here. It's not semi-supervised, but it's not an eyeballing method, right? So you define a data set and then you get a number that is sort of objectively computed, and you can use it to compare like apples to apples. Sorry, I lost my lighting here. And so I think those are like the best ways that I've seen. We haven't talked about like human in the loop evaluation. That's another topic, but yeah.
No, that I think that's a lot of good starting points. The last piece in the puzzle before we have our rapid fire chat. In terms of deployment and monitoring, you talked about it. Obviously, this for your V1 it wouldn't even exist, but your V2 or V3 of now you want to deploy. Then, like, how do you monitor? There's so many concerns. Like, how do you monitor if your guardrails actually work? Like, how do you monitor your like different parts of your for your uptime? Like, there's just how do you keep on learning or gather in a smart way, log and gather user feedback in different ways to go back to dataset building and experimentation.
Yeah, so I think that as you said, V1 usually doesn't have anything here. V2, you first would want to just dump it somewhere, right? Like that would be a major step in the right direction. It's probably be some S3 bucket or some system if you're using something that lets you log all of these things. If you can log it in the form of traces, so you already have the entire cascade, so not just the input and output, but like what context was retrieved and everything, that would be much better. And arguably, if you don't have anything, it's easier to go from like, it's not much harder to go from nothing to a more sophisticated system than it is from just like dumping it in a bucket. And then you would also, and this is sort of somewhere in between monitoring and product development, because there's a user now, right? So you would also want to build a product that encourages the users to give you feedback, because that's what you're going to use to know that there's a problem that you want to improve. So this is not something that typically an AI engineer is going to do. They need to sort of bring this up with the product engineers and have that incorporated into the system. But it's very, very important to do that. In addition to the monitoring and everything that we're doing, like that we talked about now, in a sense, a lot of the eval related things, you will have versions of those that are production versions. So even if you evaluated your model and it's not toxic, you would still want to make sure in production that it's not saying something that it shouldn't. And so part of that is going to be like if-else statements. It doesn't have to be sophisticated. Saying like, if it's using a swear word, probably don't like let it send this to the user, right? And part of it is going to be LLM based, right? So you might have a classifier to classify suspicious messages. And if there is a suspicious message, you want to send it to a smarter LLM to make sure that nothing really bad is coming out. That's one thing that we've seen in some cases and I think makes a lot of sense. So this would be like the production equivalent of LLM as a judge. Again, there's a lot of engineering considerations there, but you could do that as well. And I'm trying to think what else I heard, which I think is interesting for this phase. Yeah, like a lot of times there's also a routing component here, which I think everyone that has a production application with LLMs thinks about this, but I'm not sure that people that are pre-production know that it's coming. So a lot of times you want to combine LLM components with non-LLM components, even within the same thing, so even within a chat. And so routing between those components or experts or however you want to call them is really, really important. And just to clarify, this is not the same as having an agentic workflow where the agent can choose what to do. Like sometimes you want the human to very deterministically decide what is being called. And so you might need to build an entire component of your system to do that routing for you. And that's going to impact a lot of the monitoring and next iterations that you have, right? Because if you have a chat and part of that is in your control, but part of it is out of your control, then you need to be able to sort of separate variables and understand if the problem that you're seeing is a result of your chat malfunctioning or something else malfunctioning, or maybe nothing malfunctioning, but like not thinking through the problems in your product and how it's supposed to work for the user. So that's sort of my off the top of my head response to that.
So maybe just a simple example for this last point here in terms of routing is like you say. Do you mean is that something like when we use the UI version of ChatGPT, you get when they A/B test the models, you get two responses and you choose one. Maybe that's a little bit of a different context, but you mean in your entire flow have the end user like actions based on what the user is doing in your product, have those influence whether this is your agent or just the flow of how you plan to use the model or the chain of models.
Yeah. So I mean, all of those things could fall under what I'm saying. I guess the simplest example I can think of, again, in the trip planning example here, would be if you are creating a chatbot to help someone plan, but then you want to make sure that a human is actually booking the flights, right? So you might say like, let the model chat with a person to build their trip. And then the person will say, perfect, I'm ready to order. And at that moment, you don't want the model to think how to order the flight tickets or whatever. You want it to redirect the person to an actual like human being to book those tickets, right? I'm not commenting on whether you should want that or not. I'm just saying, like, let's say you want that, right? Like, so now you have a combination of an LLM in this workflow plus transferring to a human, which you're doing automatically. Like when let's say, again, like in this case, after the LLM shows the user the plan, it has like a button that says like approve or disapprove. And when you click approve, it redirects it to a human. So that's now like a routing model, right? That you're applying. So every time you click disapprove, you continue chatting, and you click approve, you're guided to a human to book your stuff and take you to the next phase. So that's sort of the example I'm giving here, which I think is very common in production, but a lot of times people don't think about it before they get there because it's like everyone is very focused on the LLM.
And then like all of a sudden you're trying to build something to get user to do something, and then maybe they get stuck in like you don't have really the hook to get them out of chat to do whatever you wanted them to do initially. That's actually can definitely do if you're someone focused on engineering versus the product outcome.
Exactly.
this is amazing. Like this is a blueprint, a blueprint. Definitely not bulletproof, but like this is sort of like a suggestion, um, for how for how to go from toy example to real world production grade model based pipeline.
Yes.
Um,
I hope I didn't make any mistakes, but yeah. Tell me if I
no,
did.
that's amazing. Just so we don't forget, do you have any resources that you like that you usually go to when you want to learn or read more about this?
Well, I'm lucky enough to be able to speak with a lot of people that are doing this. But I'd say like reading resources. I think that in addition to Eugene, Hamel Hussein is a great resource. He was at GitHub a while ago. He worked on GitHub Copilot, so he's early to the LLM game. And he has a lot of smart things to say now about LLMs in production. And also like a blog and everything. Trying to think who else. Those two sort of come to the top of my mind. But I read a lot. In addition to like talking to people, I read a lot on Twitter, which is for good and bad, still the best place to consume this type of information, like from the actual horse's mouth. So people just talk about what works for them and what doesn't work for them. Yeah. So.
Oh, that's amazing. Definitely, I'll put like in the description. I'll put the links to those, and people can go check those out.
Perfect.
Amazing. This is incredible. I learned a lot. Maybe very quickly, if you have on top of your mind, just a couple of tools that you find yourself go to. And this obviously it could be like Gen AI tools, but not necessarily. Just part of your workflow when you do a little bit of hands-on work. If that even happens as the CEO.
It does. I'm actually now working on an end-to-end tutorial, basically trying to cover what I told you, something between V1 and V2. But like trying to get end-to-end in the sense of you have an idea, what are the actual steps in the process that you need to go through to get to production. So in that project, I'm still like working on it. So it's not final. And obviously I'm biased and I'm using DagsHub for a lot of these things, but the tools that are underlying here are MLflow, which is great and covers like prompt tracking and production tracing and things like that. And also enables you to do the model selection piece. And if you're fine tuning, there's Label Studio that lets you do some of the ranking and things like that. Again, open source. Both of those are part of DagsHub. That's why I'm using, or that's part of why I'm using them. I am also using like RAGAS for some of the evaluation stuff. So that's one way to do things. Probably going to use Pydantic for some structured output stuff. That's pretty common at this point. And then I'm trying to think if I'm missing something. For the RAG part, so again, I prioritize open source just because I want something that users can use without having to pay. I think I'm probably going to use Qdrant for that, but possibly also ChromaDB, Weaviate are all good options. And in the end, it's more about like what fits the use case that you have. The functionality is relatively very similar. And yeah, those are the main tools that come to mind, I think.
Your go-to is a Jupyter Notebook or a fully blown IDE?
So in this case, I'm not actually representative, or at least I'm not representing what I want, what I think people should be doing. I'm doing this in a notebook because I want this as a tutorial, so like a chunk that you can just take and run end to end. So from my perspective, I'm doing this as sort of like, again, a very humble, still learning, but trying to teach people how to do this, as opposed to doing this for my own internal application, in which case I would probably use an IDE. Like I'm an IDE person when I need to write like my own projects, but when you need to instruct other people, I still think that we haven't found a better format than notebooks.
Amazing. For people who want to reach out, curious, want to learn more, what's the best way to find you?
So I am both on LinkedIn and Twitter. On LinkedIn, it's just my name, and you can find me. So Dean Pleban, Pleban. On Twitter, similar. So first name DEAN and then PLBN. You can follow me there. And those are the main places. You can also follow the MLOps podcast. So I talk to people about getting ML to production, not just LLMs, but a lot of the people that I talked about were on the podcast. So Hamel and people like Julian, the CTO of Hugging Face, and a lot of other very smart people that have talked about their specific ML in production stories. And that's it. Yeah.
Amazing. This has been really, really cool. I have now clear idea of, what's like the pro level of all of my side projects.
Well, I think that these are going to change a lot in the next few days, but I'm excited to see what people build, and I think that there's already very promising signs of this revolutionizing even more industries and use cases. So yeah,
Amazing. Thanks much.
thank you.